With our first tree created in code, we can begin to write out some application logic. Let's create a program that prints a message if the tree is taller than 100 feet. Alright, if then x is the height of the oak tree and if it's greater than 100 feet, we will print out a message. We say my favorite oak tree is an instance of the tree class. It was created from a tree class using the tree constructor and it has all of the attributes and behavior of a tree. Let's create another tree. Let's call this instance as my favorite tree 2 and give it a height as, let's say, 90 and a trunk diameter of 30 and like tree type must be let's say oak. Then we will add a logic for, let's say, my favorite tree dot height is greater than 100, then it will print something. Let's say I'm printing that's a tall tree height I will print, or the tree type first and then the height of the tree I want to print. So what it will do, it will check like whether my favorite tree, this tree has a height greater than 100, then that satisfies this condition, it will print this statement. I will check a condition for the other tree as well. So what I want to check, I want to check like my favorite tree dot height is greater than 100. Then in this case I will print that's a tall tree, and here I will use tree 2 and the tree type 2. Now it might be hard to tell between the two print statements in the console, so let's add the tree. While we could hard code awk and name tree directly into the string, let's dynamically use the instances to resolve the tree type. Let's run the code. So as of now, not one of our condition is matching. So I will update one of the condition and we'll see like what is happening. So right now I have updated the tree height of my favorite tree 2. So this condition is satisfying this thing. Like my height of the tree 2 is greater than 100. So that is why it got executed. If you change the blueprint, it affects the instance created with that blueprint. Now let's say we wanted to add a behavior to the tree class, then announce it if the tree was tall. We have already written the code to do this for our oak and name tree in the main method, but we can add it to the tree class to make this code usable by all trees. To add this behavior, we will create a function in the tree class. So what I will do, I will create a function in the tree class so that I can verify it directly from the main function. So I can use this function all around the tree class to check the height of a tree and get something as an output. So what I will be doing, if this dot height that I have and greater than 100, and then I will print something. So here instead of the favorite tree I will type this dot tree type. So it will get the instance of my current tree on which it is right now. So I will go to the main method, and instead of this statement what I need to write now, I will check for my favorite tree only. So I will do favorite tree dot announce tall tree. So it will return me the output. Let's see what we got as an output. Let's run the code. So if you see, we have received the same output. So this is how we use functions in Java. So this function is getting used 2 times, so it is showing 2 uses. We can use this function as many times as we want along different classes, different tree classes. We can also do the same with our another tree, reusing the functionality that's built in to the tree class. That's so much cleaner. You can try running the code yourself and try updating the values and playing with the code. And with the instances, we are able to keep track of various trees with their current states. By using the classes and instances in this way, we are able to bind state and behavior into one unit. This not only makes our program readable to other software developers, but also maintainable for when new trees comes along.